Alright, let's talk about the merge sort. So merge sort is pretty helpful, but the algorithm in Excel is pretty hard to understand it. And they just run the visualization first, and then we'll just see what happens next. So I'm going to sort it. So basically this is a pseudocode, right? And then you will just do the visualization sorting. So you have a point for the middle, and then you will just keep sorting on your left and sorting on your right, and until every single one is actually individual, and then you combine everything. And when you combine, right, you have to sort in orderly, right? And this will be the answer. So the sorting algorithm is pretty much it, right? So if you cannot understand it, right, you can also visit this website, and then this website is actually pretty helpful. So when I say like when you want to split, which means you have to find the middle value. It doesn't matter if the array is integer. I mean, if the array is odd or even number, you can always split into half, and once you got the left side and right side, if the length is not equal to 1, right, I mean you will just keep splitting, right? So how do I know the length is not equal to 1? I would just compare if p is less than r. If that is true, I would just keep actually splitting. So this will be the individual value, and later on I would sorting from the bottom up, right? 714, you will definitely got this one, right? And 312, you got this one. 911 definitely itself. 6 and 2 you will sort it, and later on you will just sort them back, like 714 and 312, and you will sort it back, right? And this is actually pretty standard. It's actually like you cut into half every single time, which is unlog1, right? And let's just start code. I'll just start the code, and then this is my main, and this is my array, and then I have an original array, and I call my merge sort. Alright, so I pass in the index 0, and then the array length is the length of the array minus 1, right? And I would just sort it out, and then after that I would print. So I have a constructor, so I call my constructor sort, right? So over here I need to split, so I need to find the middle value. So if I find it, I need to say if the star is actually less than n. If that is true, right, I can actually find the middle value over here. So in mid is actually equal to star plus, so n minus mid divided by 2. So this is a pretty sorry, this is star. So this is pretty helpful to have this kind of habit, because you will avoid the overflow when you have a negative value, but the index is always positive, so you don't have to worry about it. So if I find the middle value, I will just keep calling this function, sort function. So I will just sort array, and then from the start to the mid, right? And this is from my left side, and then from my right side is always mid plus 1 to n. And at the end, like at some point, right, star will equal to the end, right? And if you just rewatch this example, right, you got this P and R, which is P and R should be on the different sides, but if they're on the same side, right, you probably need to know this is the breakpoint, right? But we need a helper function to merge, right? So I have a merge. So my merge is actually depending on my array, right? I pass my array. So where's the star? I definitely know the star, and I definitely know the mid, and I definitely know the end, right? So passing the star, end, and mid. So let me just go back to the website. So this is the website I'm demonstrating. So this is like 0, 1, right? And then he has a PQR, and I have the star, mid, and end, right? So it should be the same idea. So when I want to sort it, right, I will just compare. So if I want to compare, I need to allocate a temporary variable for the array. So I will initialize my in array temp to the size of this. So which is like what, n minus star plus 1, right? This is because the size should be 2, but the index for the n is 1 and the star is 0. So you need to plus 1 be equal to 2, which which means I want to include the index 0, right? And go back to the code. So I have a memory, so I'm gonna put 10. So it's going to be new int, and then n minus star plus 1, right? Again, like you have to think about like how many size you need to keep. And later on I need a pointer, so pointer for I equal to star, and then j will become mid plus 1, and also k will be 0. So what does this mean? This is actually point to the left side of the array, and j will be point at the right side of the array, and then k will be the pointer for the temp. So let's go back to the diagram. So this is I, and this is j, and the k is the temporary array pointer starting from 0, and then I will just compare these two values. If this two value is actually sorted already, I'll just keep a pending. If not, I will just compare. And let me just do it. So you need a while loop, doesn't matter or not. While loop, so I is less than equal to what? As less than equal to mid, and also j is less than equal to m. So why I use the less than equal? Because we are comparing the index, not the actual length of the array, right? So we can use the equal sign. And I need a what? I need to compare my left side array. So array I less than equal. Okay, equal sign would be okay. And array j. If that's true, so I know like array I is always ahead of array j. So I need to append my k into my temp, right? So this is going to be my temporary k. So temp k is actually equal to array I. So once I know my I is used, I need to increment, and I also need to increment my k. So another way is if array j is greater than, if array j is less than the array I, right? So which is the opposite of the if statement. Then pretty much the same idea, but the problem is you need to have j and then increment your j, right? So once you finish, probably like since this is n, so you probably need to double check if I is less than equal to mid. If I hit a mid or j hit a mid, and then you have to just keep append your rest of the integer to the temp. So I would say, well, I is less than equal to mid, and I would say temp.k equal to array I, and then I plus plus k plus plus, and also the rest of the j less than equal to n, and then temp.k is equal to array j, sorry, and then j plus plus, and then k plus plus, right? Now I need to know like somehow I finished my temporary sorting in the temporary array, right? I need to actually modify the original array, right? So I'm going to say for loop, and then I do have I started from a star and ending for the n, right? So I equal to star, I less than equal to n, and then I plus plus. And for now it's pretty simple. You just say array I is equal to temp, and just making sure it's starting from the I, right? I mean I equal to star, right? So you have to say I minus star. So this is because you have to avoid like if you're on the right side of the array, right? So let's just go back to the picture. If you're on the right side of the array, right? The index for the left is not always 0, right? It should be like sometimes 4, right? So you have to know the temporary array should be starting from the actual index, right? The actual index is actually dependent on what 4 minus 4, which is 0, right? So this will be pretty much the solution. And let me just run it, and then let's talk about the time and space later. So I will just run my main using my merge sort, and this will be the okay. So I found a bug, and let me see what happened for my bug. And j is less than equal to temp j temp k I. Oh, this is k. Sorry. If you increment your k, if you are in the while loop for I, you increment your k and also I. This is probably the mistake, but I don't want to re-record it. So this will be a solution, right? So I made a typo. So when you want to like, okay, so I will repeat again. So once you finish the value for I and j at the same time, you have to double check, do you have the remaining value on your left array, which is from I to mid index, and also the right side of arrays from j to n index. So just making sure you traverse the rest of the integer in the array, and just making sure you copy to your original array, and this will be the solution. So let's talk about the actual merge sort time and space complexity. So this will be the worst case for the time. So U is unlog(n), and the average is unlog(n), the base is also unlog(n), and the space is all of n, right? Space is all of n. This is because you are sorting every single temporary array or every single integer, right? And is this stable? Yes, it is stable because we already know the if you have a duplicate value, and then we already know which one goes first. Be honest, because we're starting from a left array and then just keep going to a right. And the method is dividing and conquer, just using the merge idea. And this is pretty hard, be honest. If I don't review the code, I probably will forget how to actually call the merge sort. And this is not really difficult, be honest. Just think about it, and I will see you next time. Bye.